Hey everyone, in our last video we learned what Java is and why it is still dominating the software industry after 30 years. But that's only part of the story. To write Java applications with confidence and to do well in technical interviews, you need to understand three core components of Java. Those are JDK, JRE and JVM. A common way to describe it is JDK contains JRE and JRE contains JVM. While that's correct, it doesn't really explain what each one does or how they work together. That's why many beginners get confused when they are asked how Java code actually runs. In this tutorial, we will understand what JDK, JRE, and JVM are, how they work together, and what happens behind the scenes when you run a Java program. We will use a simple real world analogy to make these concepts easy to understand. Let's get started. JDK stands for Java Development Kit. As the name suggests, it is a complete toolkit for developers. Think of the JDK as a physical toolbox. Inside this toolbox, you get all the tools you need to build Java applications. For example, the Java compiler JavaC translates your human readable code into the computer code. The Java debugger JDP helps you find and fix bugs in your program. Archiving tools jar bundles your code into a single file to share with others. The JRE and JVM are also included, so you can also run your code. In short, the JDK gives you everything you need to write, build, debug, package, and run Java applications. The JDK is platform specific. This means if you are using Windows, you must download the Windows JDK. If you use a Mac, you need the Mac JDK. A common question beginners ask is, what do I need to install to start developing Java applications? The answer is always the JDK. In the past, Oracle also provided the JRE as a separate download for people who only wanted to run Java applications. However, starting with Java 11, Oracle stopped offering the JRE as a standalone download. Today, everyone simply installs the JDK. JRE stands for Java Runtime Environment. The word runtime simply means the time when a program is running. If you have already built a Java program and you just want to run it on someone's computer, you do not need the full developer toolbox. You only need the environment to execute it. That is the JRE. The JRE contains the JVM and Java class libraries. The JVM is the engine that runs the code. Java class libraries are pre-made packages like java.util for lists and collections or java.io for reading files. They contain thousands of built-in solutions, so you don't have to write them yourself. Notice that the JRE does not contain the Java compiler, JavaC. This means a computer with only the JRE installed can run an app, but it cannot create or compile new code. To remember this easily, JDK is for the creator and JRE is for the user. As mentioned earlier, starting with Java 11, Oracle stopped offering the JRE as a separate download. Today, you simply install the JDK, which already includes everything needed to develop and run Java applications. JVM stands for Java Virtual Machine. This is the absolute heart of the Java ecosystem. When people say Java can run on any computer, the JVM is the magic reason why. The JVM has one major job. It executes Java bytecode. It handles loading your code into memory, verifying it to make sure it is safe and has no viruses, executing the code, cleaning up memory using garbage collection. Think of the JVM as a translation engine. It takes Java bytecode and translates it into the specific native language of your operating system. An interesting fact is that the JVM doesn't actually know whether your program was written in Java or another language. It only understands Java bytecode. Languages like Kotlin, Scala, and Groovy also compile their code into Java bytecode. Since the output is same bytecode format, the JVM can run programs written in any of these languages. You can think of it like this: the JVM only reads the final translated file, not the original language it was written in. Because of this, you can actually write one half of a massive project in Kotlin and the other half in Java, compile them both into bytecode, and they will talk to each other inside the JVM without any issues. Let's understand JDK, JRE and JVM using a simple analogy. Imagine you are running a restaurant. The JVM is the kitchen. This is where the actual cooking happens. In Java, this is where your bytecode gets executed. The JRE is the whole restaurant. A kitchen alone is not enough to serve customers. You need a dining area, tables, chairs, staff, and menus. All of this together, including the kitchen, is the JRE. It is the complete environment needed to serve the customer. In Java, it provides everything needed to run a program. The JDK is the complete building kit. If you want to build a restaurant from scratch, you need the blueprints, hammers, and heavy machinery. That is the JDK. It includes all the tools a developer needs to build a Java program, plus the finished restaurant layout, that is the JRE, so the program can actually run. So, the hierarchy is simple. JDK contains JRE and JRE contains JVM. Now, let's see exactly what happens when you run a program. Imagine we create a file called firstjavaclass.java. First, we open the terminal and run the Java compiler using command javac firstjavaclass.java. The javac compiler converts your Java source code into Java bytecode. It creates a new file named firstjavaclass.class. This .class file contains platform independent bytecode that can run on any computer with a JVM. Next, we run the Java program using the Java command java first Java class. Notice that we don't include .class in the command. We simply provide this class name. When you run the program, the JVM starts working. It first loads the first Java class.class file into memory. Next, it verifies that the bytecode is valid and safe to execute. Once the verification is complete, the JVM begins executing the bytecode by interpreting its instructions one by one. As the program continues to run, the JVM looks for parts of the code that are executed repeatedly. Instead of interpreting those instructions every time, it uses the just-in-time compiler to convert them into native machine code for your computer. The next time those parts of the program run, the JVM uses the already compiled machine code, making the program run much faster. This combination of interpretations and just-in-time compilation is one of the reasons Java applications achieve good performance while still being platform independent. Before we wrap up, let's quickly review what we have learned. JVM is the engine that executes the bytecode. JRE is needed to run a Java program. It includes the JVM and Java class libraries. JDK is needed to develop Java applications. It includes the JRE plus development tools like javac, JDB, and jar. An easy way to remember it is JDK is equal to JRE plus development tools and JRE is equal to JVM plus Java class libraries. That's it. You now understand the difference between JDK, JRE and JVM and how they work together to run a Java program. In the next video, we will go one step further and explore the JVM architecture. We will learn how the JVM manages memory, what the heap and stack spaces are, and how the garbage collector works behind the scenes. If this restaurant analogy made sense to you, please hit the like button, subscribe to the channel, and share this with your friends. Drop a comment below. Did you already know about the just-in-time compiler, or is this your first time hearing about it? Thank you for watching. Keep learning, keep growing, and stay connected for more updates.